In this video, I'm going to talk about again static routing, but in this video, my focus is on the performance of the static routing. What is the performance? You know that we can configure static routing with three methods. The first method is using the, for example, outgoing interface, and the second method is configuring the next hop IP address, and finally the third method for configuring the static route is using the outgoing interface and also the next hop IP address. Now the question is that which method is the best method, and for example in which scenario we can use which method, and we shouldn't use the, for example, a specific method. In this video I'm going to talk about this feature, and finally after this video we will learn about what is the best method of configuring the static route. And in this scenario I want to use two routers, R1 and R2, and also two VPC, VPC1 and VPC2. First, I want to configure a static route in R1. Here in R1 we have this static route, IP route 10.200.255.255.255.0, and after that the next stop is 10.122. It is the IP address of the ETH00 of R2. This is the static route I am configuring in the R1. Then we should talk about what is the result of configuring this static route. Assume that VPC1, okay, in VPC1 I want to check connectivity with VPC2, for example ping 10.2.0.10. This is the IP address of the VPC2. You know that now one ICMP echo packet means ICMP type 8, okay, is created, and after that the IP header should be attached to this ICMP echo packet, and after that we have a data link layer header. The data link layer header is the Ethernet header, okay, and also we have ETH trailer, okay. This packet now is received with the router R1. You know that the destination MAC address of the ETH header, Ethernet header, now is pointed to the R1. Because of that, R1 should accept this packet, and then R1 should de-encapsulate the packet. Finally, R1 will receive the packet itself. Now R1, okay, has this packet. And after that, the destination IP in the IP header should be checked with the routing table of the R1. Because in the routing table of R1, we have one static route. We configure this static route. S means a static route, and the network is 10.200/24, and the next stop is 10.122. Okay, this is our static route. R1 should check the destination IP. Destination IP is 10.2.0.10 with this routing table, and you can see that this destination IP now can be matched with the static route, and now R1 knows that if it wants to send traffic toward the destination, it should give this packet to this next hop 10.122. okay, R1 now has a next hop of 10.122 to sending traffic to it, and because this links is a Ethernet link, R1 should use, for example, ARP protocol to taking the MAC address of the 10.122, and after that it can send the packet to this MAC address. Because of that, R1 now should create an ARP request. This is the ARP request, and this ARP request then should be sent to the broadcast address, and also the content of the ARP request include 10.122. This means that please give me your MAC address 10.122, and when the packet reaches to the R2, because the destination of IP of the ARP request is the destination MAC of the ARP request is quad F, means broadcast MAC address, then R2 should answer to the R1 with its MAC address. It's an ARP reply. Okay, you know that in ARP reply we have the MAC address of the 10.122. Okay, MAC address of ETH0 R2's ETH00. Okay, you know the process. R2's ETH00. Now, R1 can send the packet toward the R2. After that, R1 should use the packet, the original packet, using the new Ethernet header that contain the new MAC address, and also it should calculate the new trailer, okay, Ethernet trailer, and after that it can forward these packets to the R2. This is the process. You know the process, and we can check it. First, I want to show you the process that is occurring, and after that we can continue with the discussion. Look at here. In this scenario, we have router 1. This is the router 1, okay? Then router 2. This is the router 2. We don't have router 3. We have VPC 1, okay? Then VPC 2, and we don't have other devices. Okay, very good. Now, first we should configure this scenario with this notepad file. With this notepad file, we have configuration. ETH00 of R1 now has IP address of the 10.1.2.1, okay? ETH01's IP address, ETH01's IP address is 10.1.0.1, that's it, and we don't have another interfaces. This is the configuration of R1 in this scenario. And then R2, ETH00's IP address is 10.1.2.2, okay, so easy. And the ETH01's IP address is 10.2.0.2, okay? And we don't have router 3 and router 4, but we have VPC 1. This is the VPC 1. The VPC 1's IP address is 10.0, 10.1.0.10, 10.1.0.10 with the next stop of 10.1.0.1. That's it. And for VPC 2, we have the IP address of 10.2.0.10, and the next stop and the gateway is 10.2.0.2. That's it. We don't have VPC 3, 4, and other pieces. Very good. First, we should copy this configuration. This is the configuration of the R1. And let me to go to the CLI of the R1. This is the CLI of R1. Okay. Then CLI of R2. This is the configuration of initial configuration of R2. Very good. And finally, VPC1 and VPC2. This is the VPC1's configuration, and finally VPC2. Then we should capture the link between R1 and R2. Let me to capture. This is the VPC2. Very good. We should then capture the ETH00. This is the capture of the ETH00. Then we can use a static routing in R1 and R2 and checking the result. For the start, I want to use the, for example, with the next stop method in configuring the static routes. For example, in R1, I'm using this command, IP route for 10.2.0.0 for 255.255.255.0. Please use 10.1.2.2. That's it. Do show IP route static. Now we have one static route in R1, and then in R2 also IP route for 10.1.0.0 255.255.255.0. Please use 10.1.2.1. That's it. Do show IP route static. Again, we have one static route. Now, first I want to send the traffic from VPC1 to the VPC2. Please send this traffic ping 10.2.0.10. This is the IP address of the VPC2. Okay, we have connectivity, but what is happening now? Look at here. The first thing that we can see is that the ICMP packet, and we should find the ARP. This is the ARP. Look at here. Let me to show you. This is the ARP request, and you know that the ARP request is broadcast. Who has 10.1.2.2? This is the next stop that I configured in the router 1. Look at here in router 1. Okay, I configured 10.1.2.2 as the next stop, and as you can see, who has 10.1.2.2? Please tell me. Okay, to whom? To 10.1.2.1. This is the R1. And after that, we have an ARP reply. After receiving the ARP reply, the ICMP packets can be sent from the router 1 to the router 2. Okay, so easy. This is the first process. But now I want to talk about if you configure static routes with the outgoing interface, what is happening. This is the, for example, another option for the configuring the static route. Assume that I'm configuring this command in R1. IP route. Okay, IP